Okay, if you are in 7 Excel, we are working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. We are doing Lesson 5.3, Example 1, and it can be found on page 218. So we've been working on solving systems of equations, and we know a system means more than one. And we've used graphing, where the two lines intersect is the solution. And we've also used substitution. Today, we're going to learn a third way to solve a system of equations. We use elimination and substitution. So it's a little bit easier than what we've been doing. So the book will give us a system of equations that looks like this. X plus 3y equals -2. X minus 3y equals 16. Okay, when I look at this system, I see a positive 3y and a negative 3y. A positive 3y and a negative 3y. Well, those can cancel each other. We're going to add this system of equations together. We're going to add this system together. Because when we do that, let's watch what happens. 1x plus 1x is 2x. Positive 3y minus 3y, these guys cancel each other. Equals -2 plus 16 is positive 14. Now we have an equation with one variable that we need to solve for. So I want to get rid of this times 2. I'm going to divide by 2. What I do to one side, I must do to the other. X equals 7. Oh, that was much easier. But we're only half done. So I'm going to come back to my two original equations. I can pick either one. I'm going to choose the one that looks the easiest to work with. And now I am going to substitute. 7 plus 3y equals -2. I want to isolate my variable. I need to get y by itself. So I'm going to subtract 7 here. And what I do to one side, I must do to the other. 3y equals -9. I still want to isolate my variable. And I need to get rid of this times 3. So I'm going to divide by 3. What I do to one side, I must do to the other. Y equals -3. So we know that the solution to a system of equations is an xy. Here's my x, and here's my y. Now somebody asked me, does the order matter? Can we make it -3, 7? No, you cannot. This is at a completely different location on a graph than this. So that's a big fat no. You cannot switch the order. It is x, it is y. And this is a different solution than -3, 7. So this is a big fat no. Order matters. So it's kind of nice when we have a system of equations and we decide to add those equations to each other and we can eliminate one of the variables. It makes life a little bit easier. So let's take a look at another problem, another system of equations. The book has given us this system. 3x plus 4y equals -6, and 7x plus 4y equals -14. Okay, When I look at this system of equations, nothing cancels. I have a 4y and a positive 4y. They don't cancel each other. If only one of these 4y's was negative, then they would cancel each other. If only. Well, we do have a way to make that happen. I'm going to multiply this whole thing, the whole equation, by -1. I'm going to multiply this whole equation by -1. And when I do that, I've got -1 times 7x is -7x. -1 times positive 4y is -4y. And -1 times -14 is positive 14. Bring over my original equation, 3x plus 4y equals -6. Oh, look at this. Now, when I add these equations together, these guys cancel. So 3x minus 7x is -4x. These guys canceled equals -6 plus 14 is +8. I want to isolate my variable, so I need to get rid of this times -4. So I'm going to divide by -4. What I do to one side, I must do to the other. X equals -2. Now, I'm going to go back to my original equations, this one or this one. I'm going to pick one of my equations, the easiest one to work with, and substitute. Frankly, I think this looks like it's easiest. So 3x plus 4y equals -6. And now I am going to substitute that -2 in here. Boom. So I have 3 times -2 plus 4y equals -6. 3 times -2 is -6 plus 4y equals -6. I want to isolate my variable. So I'm going to add 6. What I do to one side, I must do to the other. 4y equals 0. I need to isolate y, so I need to get rid of this times 4. I'm going to divide by 4. What I do to one side, I must do to the other. Y equals 0 divided by 4 is 0. So my solution is an xy, and order matters. My x is -2. My y is 0. So that's what we're doing today. We're using elimination to solve for one of the variables. Then we can substitute that to solve for the other variable. So sometimes the book makes it easy on us, and they give us a situation where a variable can already be eliminated because they cancel. Or sometimes we have to change one of the equations, multiply by a negative, so that we now have a variable that can be canceled. Okay? That's what we're doing today.